So on to question number 3. Draw the Lewis structures for the following molecules. A. Nitrous acid, HNO2. Let's calculate its total number of valence electrons. Hydrogen has 1, nitrogen has 5, oxygen has 6, and since there are 2 oxygen atoms, we multiply this by 2, and when we add it all up, we get a total of 18 valence electrons. So now let's draw what nitrous acid looks like. So this nitrogen will be bonded with the 2 oxygens, and then one of the oxygens will be bonded with the hydrogen that forms our alcohol group. And this oxygen will have a double bond. And now I'll just fill in all of the lone pairs. And then we can count out all the number of electrons to make sure that they equal 18. Okay, so each bond contains 2 bonding electrons, so we have 18 electrons shown, and everything is neutral as well, so this is the correct Lewis structure for nitrous acid. So now let's look at ozone, which is O3. Oxygen contains 6 valence electrons, and we have 6 oxygens bonded together, or 3 oxygens, sorry. So we have a total of 18 valence electrons. So let's show all the oxygens bonded together with a single bond. And I'll also draw in all of the lone pairs. So one of these oxygens will have a double bond with the other. And here, let's just calculate the formal charge. So let's calculate the formal charge of oxygen on the left. The number of valence electrons is 6. The number of non-bonding electrons is also 6. And there's just a single bond to this oxygen, so we have 2 bonding electrons divided by 2. So this oxygen will have a -1 charge. For the oxygen in the middle, I'll say OM. There's also 6 valence electrons. There's only 2 non-bonding electrons, and there's 3 bonds. So we have a total of 6 bonding electrons divided by 2. So 6 minus 2 minus 4 would just be 0. And now let's do the formal charge. Oh, sorry, this is 6 minus 2 minus 3 is +1. So the middle oxygen will actually have a positive charge. And now let's do the oxygen on the right. 6 minus 4 minus 4 over 2. So this oxygen is neutral. So we can have this as our Lewis structure for ozone. Or if we were to draw its resonance structure, then we can have the following, where our leftmost oxygen has the double bond. Our middle one will still have the positive charge, and the rightmost one can have the negative charge. Okay, so now let's move on to part C of this question. Lewis structure of acetaldehyde. For the total valence electrons, carbon has 4, hydrogen has 1, and there are 4 hydrogen atoms, and oxygen contains 6. So we have a total of 18. Oh, sorry, there are 2 carbon. Okay, yeah, so this is 18 valence electrons. And the name of the compound is written in a way so that we can kind of tell that one of the carbons will contain the 3 hydrogens, and it's bonded to a second carbon that is bonded to a hydrogen and a double bonded oxygen. So now let's double check and see if it has the same number of electrons. So each bond contains 2 bonding electrons. Okay, so this is 18. So this is the Lewis structure for acetaldehyde. Okay, so now let's see what the junior tutor said. They have the following for nitrous acid, which is correct. Ozone, they have the 2 resonance structures. They didn't specify the charges, but I'll just mention that in the comments. And they have the correct structure for acetaldehyde. So this solution is correct. For ozone, the middle oxygen contains a positive charge, and the single bonded oxygen contains a negative charge. But this solution is still correct.